webinar by the Institution of Mechanical Engineers. My name is Matt Rooney and I am the institution's head of policy, and I'll be chairing the webinar today. The topic for the webinar today is artificial intelligence, and specifically harnessing the potential of AI in organizations. We're given the webinar today because we have just published a report on the same name, and that report is available to download from the policy and press sections of the IMechE website, and you'll also receive a link to the report in an email after the event. AI has been all over the news recently, and a lot of stories are often negative about artificial intelligence, but we as engineers are often more positive about technology and AI in particular, and I think that might be covered today. Before I hand over to our speaker, Alan King, I just wanted to cover some other work we're doing in this field, which is a virtual work experience that we just launched, which is aimed at children aged 14 to 16. And one of the modules is on artificial intelligence, machine learning, and automation and engineering. You can access this using the UniFrog Careers platform, and it is open both to people based in the UK and around the world. And you can register on UniFrog Careers platform and access all of that. And if you have any children or nieces and nephews around that age, I'm sure they'd love to do it. I'm going to hand over to Alan King now, who is the head of global membership development at the IMechE. He's going to talk about the report which he authored that's based on a book of a similar name. The event is going to be about 1 hour in total, and there should be time for Q&A at the end. And there's an attendee question box, so please put your questions in the chat and I will put them to Alan at the end of the event. And with that, I will hand over to Alan.
Thanks, Matt. Hopefully everyone can hear me well. So as Matt said, my name's Alan King. I'm head of global membership development at IMechE. One of the other things that throughout my career I've been very focused on is technologists, and I guess I sort of consider myself as something of a futurist. I've spent most of my life, working quite deeply with computer systems and trying to understand, I suppose, what the potential use cases for them might be. And last year, obviously, things sort of really lit up in the AI world. I say last year, 2022, in fact. And I decided to author a book on harnessing the potential for AI in organizations. And then with the conversation with IMechE, we decided it'd be a good idea to extract some of the essence of that and turn it into the paper, which we're publishing today. And we'll have links to the paper at the end of the presentation. So,
harnessing the potential of AI. Thanks for giving me the opportunity today to speak with you about the future of AI. In this presentation today, we will explore the potential benefits of AI and how organizations need to transform effectively to leverage its capabilities. I will cover a brief history of AI, its features and capabilities, and its uses and applications in the present and near future. By the way, this is not Alan speaking to you right now. I am in fact an AI-generated clone he has created, trained on his voice to sound like him. It's nice to meet you all. I'll hand over to Alan now, who will continue with the presentation. Perhaps we will get to chat again someday in the future. Thank you for listening to me and take care.
So there you go. It's a little bit of fun just to get us started. That's actually a clone of my voice that I did last year. I mean, things have actually moved on a little bit even since I did that, but that was some software called 11 Labs. And essentially, you give a very short snippet of you talking, and then it's able to fairly well articulate how you sound. And then you can just recreate that by feeding it text or indeed other voice as well. So bit of fun, but it sort of indicates perhaps some of the potential of the sort of things that we might be thinking about as we think about how organizations can actually utilize this. And if you think about an organization like IMechE, the ability to create, voice clips and potentially in different languages and other things could be quite powerful. So before we sort of get into perhaps the use cases of AI, I think it's worth just taking a little bit of a brief history of AI and sort of how did we get here? It actually goes back a very long way. I think a lot of people are aware of that, but perhaps they don't know all the detail. You can go right back to the sort of 1950s with people like Frank Rosenblatt, building machines like the perceptron, and John McCarthy, who actually coined the phrase AI, in fact, artificial intelligence. And that's all happening, perhaps a long time before we even think of computers as being, serious systems. And of course, there's Alan Turing as well, with the Enigma machine and the work they were doing there. As things move along, it's had its ups and downs and its highs and lows, and there's been several what have been known as AI winters, perhaps where development has slowed down significantly, or perhaps the kind of technology to support what they're doing hasn't quite been there, and then it's almost waiting for technology to catch up. And we'll talk about that in a moment and how that happened recently. But if we think about our lifetimes, there's been kind of three really game-changing innovations. Well, certainly my lifetime. I'm 53 years old now, and in that time I've sort of seen the arrival of the desktop computer, which really changed everything. I remember, when I was sort of 10 or 11, 12, my father sort of getting our first sort of desktop, and being, quite blown away by it. Really, it was quite a jump up from the previous computers I had, which were like things like the Sinclair Spectrum. And suddenly you realize, actually, this is a serious machine that, is going to change the way offices work and function. And of course they did. The typewriters went out the windows, and in came the desktop systems and the printers and everything else, and kind of changed the way people thought about systems and how they could use it in their lives. And then the next big breakthrough and change, and I was very much in the working world at this point, was the internet. And when that sort of crashed into our world in the kind of mid 90s, and the arrival of things like Google, and obviously the ability to build websites and create an online presence for your organization, it really, again, moved everything, moved the needle. And I sort of watched organizations at that point shift from being very sort of paper based to digital in the space of about sort of 10 years, and it was quite a transformation. And then the most recent change has been the kind of mobile world, mobile computing. And I think really, although there were mobile phones before the iPhone, I think it's the iPhone that really kind of suddenly ignited it and changed everything. And suddenly, the ability to have this big screen in your pocket, you can watch video. It led to the creation of things like social media, TV changed forever, moved to platforms like Netflix, and really the whole world kind of reorganized itself around mobile computing and mobile devices. So those have been sort of three huge things. And I think where we are now, we're on the precipice of the next big change. The AI revolution is undoubtedly upon us. I think it's realistic to think that it's going to be at least as big as any of the three I've just described, if not bigger, potentially. And of course, it only really happens because of the other three that've gone before it. It's a bit like if you stand on the shoulder of giants, as Einstein said about Newton. It's building upon what we've already kind of achieved and then taking things to a new level. So what has happened in recent years, and what has been the sort of big change that has got us to where we are today? Well, I suppose more recently in AI, there was a big breakthrough in 2012 around sort of deep learning algorithms. A system called AlexNet was developed by Alex Krivetsky and Elias Escobar, and they were both students of Geoffrey Hinton, actually. And they basically built an image recognition system that could have basically look at what was on the screen and then describe it in quite some detail. And there was a competition that was run every year, and they built this system that was really a step change away from anything that had been done before in that world. And suddenly the world of computer vision kind of took off and became a really important thing. And that sort of took us forward then into 2017, when Google wrote a paper about the transformer architecture called Attention is All You Need. And at the time, people who were sort of watching the space kind of realized, this is actually really quite important. But we didn't really see the fruits of that until 2022, when OpenAI sort of released upon the world their 3.5 large language model, ChatGPT. And I think that was the real wow moment. And it's sort of ironic that Google perhaps didn't and weren't the ones to release that first model, given that they sort of written a paper on it. But I think part of their business was so tied to advertising and search that I think in a way maybe they thought they would be kind of cannibalizing their own business. So I don't know. There's probably quite a few reasons why they were hesitant, but ultimately, it was OpenAI that kind of drove that through and sort of brought this into the public consciousness and where we are today. So what is a large language model then? What are these things that we keep hearing about? And again, it's worth just kind of like reflecting through some of this, because it helps us understand what then the use cases might be, and also importantly, what the limitations might be if you're implementing this across an organization. So what I've tried to do here is lay out a kind of comparative to the human brain, because I think otherwise it's just numbers on a page. If I just tell you about large language models, you kind of go, yeah, I've got no context for that. So by laying it aside, the human brain, it at least gives us some kind of scale and sort of context. So, you know, a neural network, a typical large language model like OpenAI's model, would be around 175 billion parameters, and they lay that across about 100 plus layers. Now, we don't have the exact figures on that. OpenAI are quite close about that, despite being called OpenAI. But you know, that's pretty much what the sort of the thinking is. And to give some context to that, the brain has about 86 billion neurons. The difference here, though, is it doesn't have layers as such. It has thousands of synapses leading to hundreds of trillions of connections. So it's sort of wired slightly differently, and you know, ultimately giving it a lot more connections than the current neural networks. However, that we shouldn't underestimate the scale of the large language model, because it really is large, and perhaps the word large is underselling it. And typically, an LLM data set would be around 10 to the power of 13 tokens or words. A token may not be an entire word; it may just be a part of a word. But if you were to sit down and read that, it's probably going to take you about 170,000 years if you were doing it for 8 hours a day. So that gives you a feel for, you know, the kind of scale. And that sounds a lot. You think, wow, okay. But actually, a 4-year-old who's been awake for around 1,600 hours, they reckon the amount of information that it's received is about 10 to the power of 15. You might think, well, hang on a minute, how is that possible? And that's because it's getting visual information as well. And this is where large language models, you know, we see a weakness then versus the human brain, because the human brain is able to take all this visual data in that can't reach a large language model. So that it's actually quite impressive then to think that a 4-year-old is taking on that much data visually as well. And that sensory input that the child gets creates a lot more information about the world, right, around it. It starts to understand, you know, things like gravity. If you drop something, it falls. If you know, and it starts to gain a level of knowledge that you won't see capable of currently within a large language model. Although there is one thing about the large language model which is useful, is that the data is essentially compressed. So because things are described in a sort of articulate way, it means that you can create information about the world, perhaps in a more compressed way, albeit perhaps without quite the same level of detail. So the average large data set, I deliberately chose a 50-year-old here because it's me, but the average large data set is about the equivalent of 50 humans, basically, in terms of, you know, in terms of language data. Not my visual data, I've got a lot more, but in terms of what I might have learned through language in my lifetime, that's quite big. And when you think about that, you know, that's about, if you're asking it a question, that's like having 18,000 friends you can ask in Phone a Friend or something to get the information you need. So it's a lot of knowledge. The human brain, though, as I say, outperforms it with its vast visual data set. It also has, the human brain, what's called persistent memory. And this is where large language models kind of falter a bit, because they have very limited memorization. In fact, the only memorization they really have is the context window that you're prompting in, and potentially some reference data if you've uploaded some folders and documents and files. But even that's limited as well, because when it runs a query, it can only reference so much. For example, I recently tried to upload a book that was 7,000 pages, and GPT kind of just fell over and went, I can't deal with that. And what happens with memorization in an LLM actually is that each time you ask it a question within the same conversation, it's actually resubmitting everything from that conversation again and again and again, and you're just adding a prompt onto it each time. So it's not memorizing anything really that you've told it. You're just getting an increasingly longer prompt. Now, to the user, it doesn't feel like that, because it feels like you're just replying to the most recent response, but that's actually not what's happening. It's resubmitting everything that was in that prompt again. You know, and so as you would imagine, that becomes limited, and through exchanges, you probably run out of the ability to, you know, sort of recall back to something you told it earlier quite quickly. It also has no real ability to understand the world. As I said, it has no visual cortex, no visual data. It doesn't build a world model around things like gravity, and as I said, stuff like that. So, and that also limits its ability to reason and plan effectively. It cannot plan hierarchically, for example. It can, you know, respond to a question and give you an outcome. But if it's got to work through a staged hierarchical planning process, you know, if this happens and this happens and this happens and this happens, what do you do next? It really would struggle with that. So what else can we tell you about the models? They're autoregression models. They probably should be called, autoregressive large language models. And the way that works is when they train the data set, they're effectively getting it to look at the next word to the left. We'll blank that word out in all the training data and say, what should it be next based on all of the information that you've got? And over time, quite quickly, I suppose, over time, but it learns to guess what that next word's going to be. So when you prompt it, and you ask it a question, it's able to work out what the next word ought to be. It produces that word and then feeds that back into the question, if you like, and then produces the next word and so on. And that just repeats as it creates the text that it's generating for you. The temperature is worth mentioning. This allows us to control the accuracy. So when you're asking it or when you're using the model, it's essentially creating a sort of probability of what the next word's going to be. And the temperature allows it to say, well, what's the most likely word or the slightly less likely word to come up? And by controlling the temperature, you can allow it to be a bit more creative and say, well, actually, it's okay for you to use perhaps not the most probable word. Maybe you'll go for something that's slightly less probable. And then you start to get more creative outputs. And obviously, if you're doing marketing and stuff, that's really helpful. Obviously, less so if you're looking for accuracy, perhaps in the engineering context. Prompt engineering is key to, I'm not that keen on the term prompt engineering. We're engineers here, and I think we perhaps have a different definition of the word engineering. It's asking the system questions effectively, but that's actually quite important. And how you ask the questions and the context and information that you give it really does define what the outcome is. Because as I said, in the end, everything's all in this context window, and that ultimately defines what the output of the system gives you. Limited memorization. Again, we mentioned that before, because of the context window stuff. But there is some, so you can have this kind of back and forth. And that was one of the big jumps really with GPT, was that for the first time you could have a chatbot that you could really have a conversation with, albeit, you're probably limited to about 20 or 30 exchanges before it starts forgetting things. Like, so if you told it something about your personal information or whatever, 20 or 30 questions in, it may well have forgotten that because it's now exceeded the size of the context window. And then the other big breakthrough about LLMs was that their ability to weigh the value holistically rather than sequentially. So models up until this point particularly were trying to work through things sequentially, and essentially that would create quite a slow process. And what LLMs are able to do, because of the way the architecture is designed, is to be able to kind of look at the whole thing, the whole context simultaneously, and weigh it against its training data and give you that response very rapidly. So there's a couple of models I'm just put on the screen here. One you'll recognize perhaps from the icon is Siri. And in fact, this has just been updated this week. Sorry, Siri's now going off on my iPad. But essentially, the thing about Siri is historically it's been rule-based decision tree modeling using NLP, machine learning, which means that it was never capable really of back and forth conversations or storing personal information about it really didn't have any kind of context window to work with. It also didn't have access to a large data set in the way that LLMs do. And in fact, Apple this week, when they announced their kind of Siri 2.0, if you like, they're still having to call out to GPT for more complex questions or information because they still haven't got that kind of large language model baked in. Pi, on the other hand, is a large language model. You might not be so familiar with Pi, but it was developed by Mustafa Suleyman, who's now back in the UK. He recently founded Google's DeepMind back in 2017, and then went off to do his own thing at a company called Inflection and developed this chatbot called Pi, and it's very much trained on conversational data, which makes it really chatty and really easy to talk to. So the comparison between talking to Pi and Siri is really night and day. I can sit there and have a conversation with Pi for hours. In fact, I've interviewed Pi, for a podcast once, but you couldn't do that with Siri because it just doesn't have that capability. So what's the benefit of all of this to us? Well, you can create efficiencies. The ability to now automate repetitive tasks using LLMs and enable organizations to start operating more effectively. The opportunity for that is actually massive. If you are an organization and you start going and looking at how you run your business and all the kind of activities that take place, and think about where AI can intersect, you should be able to find lots of these efficiencies. And also data analysis. One thing I say a lot when I talk to people about this is, AI actually for the first time makes data work. We can now start to see the kind of insights we've never been able to get to before. Insights that are beyond human capability to find because of the scale of the data. Suddenly we've got systems that can actually really analyze those. And we're starting to see that in the kind of medical field already, some major breakthroughs. The ability to personalize as well, like never before. Many years ago, on my master's, I did my thesis on mass customization, and I talked about the ability then to personalize, products and technologies for individuals. Well, this will take this to a whole new level, and systems will literally understand you, recognize you, and talk to you in a way that's so personal. It will really feel like you're talking to another person. Innovation, absolutely, both in terms of what we can create, but also the process of that creation as well. It should speed up innovation. It should accelerate what we do. We'll see that in a minute. And it should take us to new places really very quickly. And then the ability to collaborate. Again, AI, breaking down barriers, connecting people across geographies and language barriers and cultural barriers. It gives us the opportunity to do that and share information quickly in ways that we've never been able to do. The ability to just summarize meetings and activities and information in a really elegant way fast is going to be really powerful once we start to implement it. So where are we now? Look, there's a lot happening, and it really feels like the kind of Wild West at times, I think, with the stuff that's being announced, on a kind of weekly basis. And some of it, I think there's a lot of companies out there who are perhaps have a philosophy of kind of, move fast and break things. And then there are slightly more measured organizations like Apple, who this week announced their sort of tools, which are seem a little bit more calm and measured. But there's lots of stuff happening, and you'll see it happening across all of your products that you're using, across Microsoft Office, Google Docs, all of these areas. You're going to see AI popping up. I was in Adobe yesterday, and there's now a new AI feature in there where it can analyze a document for you. But email, your presentation, documents. There are chatbots now that you can talk to. I often talk with chatbots now just to brainstorm ideas. In your text, your email, your Word documents, all those kind of activities, again, are going to be transformed. And of course, social media, we're starting to see the emergence of chatbots and information there as well, again, that can help you assist with generation of content. And of course, mobile, it's going to be, your phone probably will become your AI assistant in the very near future. And we at IMechE, we've built an assessor tool actually for our membership development team who assist people who are looking to get chartered. And we've been able to do this, and essentially they can use this tool when working with a candidate and help assess what they're doing and what they're saying against the different competencies areas. And it helps to give a really detailed and supportive output for them in a time frame that's much faster than it would have been previously. But a lot of this comes with fear as well, and I'm sure we've all seen headlines on the newspapers, and what AI might do and change the world. And look, I'll be honest. I think that AI is going to turn every part of every organization inside out over the next decade. As did the internet, as did mobile, as did the desktop computer. I don't expect this to be any different. If anything, I expect it to be probably faster than some of those. And organizations, they should try and embrace this, though. They should fear becoming irrelevant much more than they fear the change itself. And there's an opportunity here for organizations to really sort of grasp this and say, well, actually, we now have the opportunity to do things perhaps we've only dreamt about doing. And, if we work with this, technology, we can position ourselves very strongly, in the market. Kodak was a company that famously didn't do this. I've got a little audio clip I'm going to play here. You'll be pleased to know my AI assistant is back to tell you all about it.
Oh, hi. Alan's asked me back again to explain the Kodak story. Here goes. Kodak is a company that was once synonymous with photography. Founded in 1888, it became one of the most successful and influential companies in the industry, with a reputation for innovation and quality. However, as the world moved from film to digital photography, Kodak failed to adapt and ultimately filed for bankruptcy in 2012. The story of Kodak's failure to embrace digital photography began in the 1970s when an engineer at the company named Steve Sasson created the world's first digital camera. However, instead of investing in this technology, Kodak focused on its traditional film business, believing that digital photography was a fad that would not catch on. This was a major strategic mistake, as digital cameras soon became more popular and affordable, and consumers began to abandon traditional film photography. Kodak's failure to adapt to the digital photography revolution can be attributed to a number of factors, including a lack of vision from senior management, a reluctance to invest in new technology, and a failure to develop a viable business model around digital photography. The story of Kodak serves as a cautionary tale about the importance of innovation and adaptation in a rapidly changing business environment. Thanks for listening. And now back to Alan.
There we go. So, I think we all want to avoid being Kodak. So how should organizations respond then? Well, this is an inflection point. I think the sort of chart here sort of illustrates that really. There's this moment where suddenly, human intellect and machine intellect start working together in unison, and it really sends us up a cycle of development that's much faster and creates this sort of transhuman capability that we've never really seen before. And some people say, well, it's a kind of singularity actually, and it will speed everything up, and that this change could happen much faster perhaps than some of the previous ones. And certainly that is something which is understood quite well, I think, in terms of sort of how technology's changed the world. If you look back across the last sort of 10,000 years, there's been far more transformation in the last 200 years than we've seen in the sort of previous 10,000. So it is definitely speeding things up. And for organizations, being a first mover could be important. It can be important to grasp and understand that technology, not sort of lag behind. I think also organizations shouldn't see this as an IT problem, particularly. It's a strategic problem for organizations to think about and how they integrate that into their business. Much like the internet, when that arrived, that affected everything from the post room to marketing to HR, to services, whatever aspect of that business was. It wasn't a case of, well, we just plug the internet in. It was, actually our business processes, the way we organize ourselves, the way we run is going to change. And so you need to think about it like that. And most IT departments are also very busy keeping the servers up and the networks going and the day-to-day activity. It's hard for them to sort of find time sometimes to then think about how you can deliver a step change as well. So I think my recommendation to organizations is that there are people in the organization specifically thinking about and focusing on AI development, and that you create this kind of mindset with stakeholders across the whole organization, that people are buying into this, thinking about how in their departments it can be used and delivered, and how they can help engage and develop that process really. So in the book, I developed this model which I've called the 5-layer integration model, and it basically looks at an organization from kind of top to bottom and says, well, what are the things we need to really think about? And the 5 layers are the sort of back ends of the organization, the data, and what you do with that, and how perhaps your data needs to be cleaned up and sorted out. If you haven't got clean data and you're going to start integrating it into AI data tools, you're going to run into problems fairly quickly. I think the old adage isn't it? Rubbish in, rubbish out. I think that's almost like kind of day one activity really for AI. It's just, let's get your data straight to begin with, and build a back end as well that is able to integrate with future services that are coming. And then from the front end, the customer facing stuff, your website, develop usable systems again that can then enhance value for your customers. But here there are some caution needs to be applied as well. I think you can go too fast here. Don't put chatbots on your on your web page that are sort of spouting nonsense because they're not properly aligned or fully developed yet. So there's caution around the front end, but it's certainly you can't ignore that, because that's what the world and your customers or users are going to see. Another aspect of the organization is the kind of pan-organizational scale of all organizations, that you have different departments to think about. It's no good just doing AI, in the IT department or marketing. It goes across the whole business. It's this strategic thing. Where does this all fit? How does this sit? in different departments, and you almost want to go through a kind of mapping exercise and understand what the kind of process flow is for each of those departments, and where AI could reasonably, help and support activities and improve process flows, and where it isn't appropriate. And also, that's probably something you would revisit fairly regularly as well, and understand that the AI capabilities are changing, and what might be possible, or not possible today, could be possible in 12 months' time. So again, I think really important part of this. Another layer is the staff support. For people working in organizations, they're not all AI experts, and they can't be expected to be. So again, if there's an onus on the organization, to reach out to its staff, help them understand what is actually happening, the kind of tools that are coming when they see things appearing in, Microsoft 365, or, things that they're already using. Should they be using it? How should they be using it? What should they be doing with it? Some kind of training and support and development for staff, and particularly around kind of concerns around AI as well. And is it going to take their jobs and that kind of stuff? Really, really important. And then there's the sort of top level, which is the public facing thought leadership layer. Most organizations these days have a sort of public profile, particularly in things like social media as well. And how are they positioning themselves in this AI landscape? Again, an important activity. Today IMechE, we're talking about AI, so that's part of our public facing activity. And it's important to show that we are thinking about this, and how organizations can come to us for support and guidance. Now, all of this is a process that you need to go through. You need to look at each of these layers. You need to analyze each of the layers first. That's kind of step one. What is the kind of current position? What's the situation? What can we learn from recent history as well? Once you understand that, you move into a kind of consolidate phase where, okay, what have we got right now that we can use? What are the quick wins? What are the things we can do today? And then when you've been through that process, you move into the kind of innovation phase. How can we take this forward in the future? What's the potential here? What are the things that we can, hopefully do and iterate on? Part of all of this as well in the book I described was the sort of human AI data dependency. There's a lot of people, when you talk to them, they get very concerned that AI is just going to come and take all their jobs, and what will they do? Well, humans are a really key part to AI, like an essential part. They drive everything, right? Humans first will create the AI. They also operate and run the AI, and AI is very much a co-pilot with humans, in the driving seat. And then next to that, humans also create all of the data that AI systems are going to run on as well. So, you can't have these systems or these force multipliers without humans being involved. And then the AI works with that data and makes it work, and gives us something like the like of which we've never seen before. And that gets us to this force multiplier where, with humans working with AI, you create this kind of co-pilot dependency that gives us that kind of magic performance and output that, hopefully we can all benefit from. So, if you're an organization, you go through this AI adoption phase. There's the cultural side of things. There's the, you need to embrace it as a business. You need to think about it, how your organization is going to respond to this, from the very top down. You need to think about the kind of talent in your business, how you develop that, help train, support people, and of course, perhaps attract and bring new talent into the business. You need to think about the data side of things, as I said earlier, and then that kind of collaboration, and also the ethical use of it. AI and ethics is a really sort of key point, and you can't just roll stuff out without making sure that things are being done responsibly. You need to be very careful about the models you're using. You need to understand what the potential pitfalls are, what the outputs are going to look like, and you also need to think about, in terms of your employees and their roles and jobs, what it means for them as well. So there's a whole piece of work around ethics to be done. You'll also want to measure success. Everyone wants to understand what the benefits are. So you look at things like efficiency gains that can be achieved through AI by, putting AI into business process flows. What can be done, what can be sped up, what can be done easier. For example, the assessor tool I mentioned earlier that we built at IMechE, that's certainly helping our membership development team. And then, are we seeing improvement in customer satisfaction levels? Again, you can measure that with your customers or members. Are your employees engaging with this? What does that look like? What's the KPI around that? Innovation, are you getting to innovation outcomes quicker than, say, you were 12 months ago, 18 months ago, 2 years ago? Is it helping you improve the performance around those areas. And of course, I suppose the bottom line, what difference are you seeing, or in financial performance? How is it assisting there? I mean, these are some things you might look at. There are obviously a lot of other KPIs to consider, but perhaps these are the most sort of common headline ones. So where are we today? There's lots of tools out there, and to be honest, when I wrote this list a while ago, it's probably out of date about an hour after I wrote it. That's how quickly the space is moving. But some of the common tools you'll be aware of in the large language model space, things like GPT-4 Turbo and GPT-4o actually has come out since I put that slide together. Copilot, Microsoft is pushing really hard now on Copilot. There's Anthropic's Claude is very good as well, and of course Google Gemini, although I do lose track of what Google are calling their models. They seem to change on a weekly basis. And some very good chatbots that I mentioned, Pi earlier. AI to video for marketing can be very useful. Things like HeyGen, Synthesia, Runway Waymark all help you generate videos and also presentations, and things like Slides.io in Google. Actually, you can drop in a report and it will create a PowerPoint for you. And indeed, that's coming to Microsoft PowerPoint as well now. And then if you want to generate some audio, I mentioned earlier 11 Labs. Whisper and Synthesia as well. Again, very good at that sort of thing. And even down to things like generating AI avatars. Now, I know some friends of mine in my AI network who regularly create videos now using AI avatars of themselves. And it's always actually quite hard to work out which, when they post them up, which one was the avatar and which one wasn't. That's how good it's beginning to get. And text to image, we're starting to see that really become a thing now. Midjourney, Stable Diffusion, DALL-E have got very good in the last 2 years. 2 or 3 years ago, if you'd looked at an output from DALL-E, you'd have kind of gone, ooh, but today the quality is very high, and of course, it's only going to improve. Text to video is coming sooner, and Runway and OpenAI, have a model coming, which they haven't released publicly yet, but we see lots of tests running on it. It looks very impressive. UI design, Galileo. There's also translation now. It's very easily done. And in fact, large language models are particularly good at translating, actually, because what they don't do is just do a kind of word-for-word translation, which is the way it always used to be done with computer systems. Now they holistically understand the context of what's being said and effectively write it in that language. So you actually get a better output than you would have done with previous systems. And then knowledge translation is really interesting, because this is kind of a new thing, I think. Age level and knowledge translation. You could now take a document. So if you took an organization like IMechE, we might have a very technical paper that's published, and we might think, well, there are some key points in here that might be really interesting to a 14-year-old if only it was written in a less technical way. Well, you could very easily now run that through a large language model system and get it to create a translation of that effectively into a more user-friendly presentation for a 14-year-old. And you could do that in minutes, whereas previously that would have taken an awful lot of work for somebody to sit down and kind of work that out and extract it. So knowledge level or age level, if you're working in a very technical area in engineering, but you need to present the kind of what's the point of all of this to the marketing team. Well, maybe you run it through a knowledge translation and say, well, take this technical report, but make it work for someone who works in marketing, and you'll get something that's probably more useful for them. So yeah, I think these are kind of areas perhaps we've never thought about before. I'm going to show you a little video now. You'll see my picture on the screen there. Well, you'll see, this is me. I don't speak French, I suppose, is the only thing to say about this video. But I found a way to do it.
Salut et bienvenue dans le laboratoire de test de traduction vidéo. Profitez de votre expérience ici. Donc, j'utilise le HeyGen, IA. Je vais vérifier si je peux faire traduire ma voix dans cette vidéo, disons en français, pour voir.
Okay, well, we're a bit tight on time, so I'm going to move on from that. But you get the idea there. And imagine if you're an organization and you've got members all around the world, and you've got a presentation by somebody senior and you want to be able to send that around the world. Well, that could be quite a neat way of doing it. And, you can literally take a video and just turn it into any language you want, and it's done the lip sync. It's made it look, pretty accurate. And of course, all of the stuff we've just talked about there is the worst it's ever going to be. All of this is getting better literally by the week. So where do we go from here? Well, you often hear talk of AGI, artificial general intelligence. This is like the next level of systems. I personally think this is actually quite a long way into the future, maybe 15, 20 years. Others see it more short term than that, but I don't. But it's a system that can really do anything. Current models are, as we said, have limited memory. They don't have long-term planning. They don't have complex reading. So we can't quite build a system at the moment that can just do whatever and anything. The idea of AGI would be that it could do that. And as such, it can sort itself out. So you end up with a process flow where, you give it a task, the AI determines any information it needs. It then goes and finds that information itself, comes back, tries to redo the task, still hasn't got enough, go and do that again. Come back, I've now got enough, I'm going to just go and search this knowledge as well. And when it's been through this whole process and got everything it needs, it then successfully completes the task. And we're not at those systems yet, that kind of AGI level, but I think, that's where we get to eventually. And then the future of work then changes slightly, towards kind of all you saying, what do you want done rather than how are you going to do it yourself? So you're talking to systems, and perhaps in the engineering world, we're talking to systems and asking them to help us develop the design, and we're giving them the parameters and saying this is what we need to achieve, and then the system is going away and really working to solve that problem. So we'll just get into the end, which is good because we're just on time. Just to say a couple of highlight things. Future events coming up on AI from IMechE. On the 20th of June, there's another event on condition monitoring of fluid machinery using AI. And then 25th of June, applying AI in pharmaceutical manufacturing as well. They're all free to attend, and they will also be available on YouTube shortly thereafter. And the last thing for me to say really is, let's start a conversation. I'm always happy to talk to people and discuss AI with them. There's a QR code there which will take you to my website where you can find my book, which is gets into more detail about what I've been covering today. There's a bit.ly link there to the paper policy paper that we're publishing today. Obviously, you can find that at the IMechE website, and I believe that you should be receiving an email after this event with links to the paper as well. So hopefully you'll enjoy that. But I think that's me. I'm going to stop talking, and I think we're going to open up to questions now, Matt. Is that right?
Yes. Thanks, Alan. And thank you to AI Alan and French Alan as well for that fantastic presentation. For attendees watching online, please do keep adding your questions to the attendee question list. We got a few minutes to go through them. I might use chair's prerogative at the beginning and say your lessons, Alan, are valid for all types of organization, whereas we are an engineering organization at the IMechE, and we've probably got many engineers watching. So are there tools that you think are most useful to engineers, or good examples of engineers using AI to analyze data or things like this? Or what do you think are the most relevant things for engineers and engineering organizations?
Yeah, good question. Thanks. Yeah, I think at the moment a lot of the tools are very sort of general in the way that they're being developed by the sort of the big tech companies, I suppose, in Silicon Valley. And there's certainly limitations on the kind of data sets you can upload, and I would be quite cautious about uploading large data sets to any kind of public model at the moment. So it may be if you had sort of commercial sensitive data that you would want to build your own what's called a narrow model, and you can do that quite easily. Actually, there's a lot of tools out there that allow you to kind of build them on device, on your own systems or servers, or even I've got some narrow field tools running on my MacBook that would then allow me to load in fairly significant data sets, which I could then build a prompting model that will then interrogate that data. But I think what we're going to see in the engineering world, as we're seeing everywhere else, is in a lot of the sort of frequently used software that engineers might be using, and this kind of CAD stuff, all of that, AI increasingly being baked into it, and we'll see AI functionality and options probably in systems that you used previously. It might then say, well, you can do an analysis here, click this button, and it will allow you to sort of dig deeper. So I think there's sort of two levels to that. As I said, there'll be the sort of baked in stuff that comes from the software that you're already using that will just be updated in new versions, and then the ability for organizations to perhaps build their own model that contains their data, their information that's sort of kept away from, somebody else's cloud server, and then it can be used to analyze and understand. And I think for engineers, that's a really big opportunity, because it feels to me that, we often have very big data sets in the engineering world that humans can struggle to kind of sift through. And if you can get a system that understands your business, and I mean really understands it, and is able to sift through that, I think the potential for insights are profound. And we've seen that in medical already. They seem to be a bit ahead on this. And we've seen already some fairly significant breakthroughs in medical science as a result of AI, scanning and looking at large data sets.
Yeah. Thanks, Al. We've got a related question, which I'm not sure if you've covered with your answer, but it's how can industries deal with massive in-house non-structured data? Can AI help with that?
I think, just trying to understand the question a little bit. I think essentially its ability to sift through it, and it's almost perfect for it in a way, isn't it? Because if you've got a load of information that isn't structured, it's probably AI is the right thing to try and figure it all out. It's the beauty of an AI system, and actually when its ability, as I mentioned earlier, to look at stuff holistically, and then find, if you like, relationships in that information is unlike anything a human being would probably be capable of doing. So it's almost a case that you can take all of this information. It doesn't need to be kind of pre-ordered or put in a particular structure. You can just kind of throw it at it, and it will work out. And a good example to try that, if anyone wants to try it for themselves, is you could take a document, jumble it up, right? Literally get all the pages of the document, mix it all up into, in the wrong order, chuck it into a language model, and then ask for a summary of that document. And it will give you a perfect explanation of that document,
Yeah, thanks, Alan. This is a question from Tristan that might be more something for us in the policy team to go away and think about, but it's what is the biggest efficiency savings you've seen from AI implementation? And he's asking specifically in engineering companies, which you might not have the answer to, but what are the types of efficiency savings you've seen?
Yeah, I mean, I think personally, well, so first of all, IMechE, we've seen some efficiency savings within our own team. I mean, that's obviously on a kind of, fairly small scale, but if you scale that up across big organizations, the opportunity to save individuals' time could be enormous. So if you took a large engineering organization in the UK, something like, let's say, Rolls-Royce or something like that, maybe they've got 20, 30,000 employees. Imagine if you're able to save, each of those employees 5 hours a week through AI tools. That's quite significant, isn't it, in terms of man hours saved and time saved. So, and actually what you're able to do in that scenario, I think, and what the goal should be, it shouldn't be about well, we need less employees. Actually, what you should be thinking is, actually we can now get more from our employees, more output. So it's not about cost saving, it's about perhaps 5x 10xing your output or your performance. And that gives organizations an opportunity to then go to the next level in terms of what they're doing. I mean, I have seen online videos of engineering companies who've been using AI tools to sort of help them design and develop things. And a good example might be where they were sort of designing, sort of blades for wind turbines, and they were able to get the system to iterate out 3 or 4 designs in a space of time that was much quicker than perhaps the human team would have done it. And then the humans were then able to look at those 3 or 4 designs and then work through which is the kind of most optimum one to think about and why. And it got them to that kind of end state of making a decision much faster than they would have done if they'd started themselves just with a blank sheet of paper and nothing else. So I think we'll find out as we go along what the opportunities are, but one thing's for sure is that there will be big opportunities.
Okay, great. So we've got lots of questions coming through. We'll get through as many as we can in the remaining few minutes. So there's one here from Rob on why companies might be reluctant to implement AI in their work. What are the potential risks? Is it because of a data leak? Or what do you think might be a driver for such companies to overcome this reluctance?
I think there's a lot of reluctance actually right now. I think companies are a bit afraid of it. I think they're nervous. They're not quite sure what to do. Is part of the problem. Certainly data is an issue. They're concerned about IP and where's this information going and who's potentially could get hold of that. There's obviously the ethical side of things as well, that they're worried about, sort of doing the wrong thing in that arena. And, also, I think they're worried about investing in something and thinking, well, what do we invest in actually? What is the right thing right now? And that is tricky, because obviously everything's changing really fast at the moment. So if you're a business and you're thinking, well, we've just invested already last year all this money in capex and these systems, and are we saying now that we're going to change everything? We sort of feel we still need to get our value from that system. So I think companies, organizations will be not rapidly adopting this stuff in some scenarios, and because they've got their kind of legacy infrastructure in place already that they almost want to kind of utilize first. But they will have to, and they will need to adapt in time. But I think at the moment, it's only been 18 months since GPT kind of crashed into the world, and everyone kind of went, well, what do we do? I in my mind, I have a kind of 3-year time frame on this, that from that moment to about 3 years, and then it's about that point that organizations really start to wake up to it and start appointing perhaps an AI head level or director, and actually start to really, in the same way we've done in other things, with like around risk, you might have something in your business thinking about it, or I think organizations will start to really drive it, but I think that's probably still about 18 months away. I think at the moment it's still kind of like the dust is settling and people are trying to work out what is the way forward.
Yeah. What about reluctance at a personal level, Alan? Because we've seen that employees might be reluctant to change. We've seen it on much lower tech level, on things like going to paperless office, where people will just still print out everything. Yeah. Are there anything organizations can do to engage with their employees who might be reluctant?
I think educate, really work with them, explain to them how it can help them, show them the benefits. When I did this with my team, with the assessor tool, I was very clear when I sat down to them and said, like, this isn't a threat to you. It's not here to do your job. It's here to actually automate a process that can be very mundane for you, and actually allow you to have more time to do the more interesting parts of your job and focus on that. And actually make a task that was probably quite laborsome, much more straightforward. And, I think when you explain it to people in that way, they're generally okay. It's a bit like when the calculator came along, I'm sure there were people with slide rules who were kind of going, hang on a minute. But actually, it's taking us forward, and it is useful. But yeah, I think you can't just throw it at people and go, there you go. There's a big piece there. And I think organizations need to be really mindful and spend time, with their staff explaining this and supporting them through the process.
Yeah. We've got a great question here, which is highly relevant because we've got elections in the UK and all over the world. And the question's about AI beginning to be used during remote interviews. Are there any telltale signs to look out for, or tips you can give for spotting an AI?
Well, the extra finger is always one, isn't it? The 6 fingers instead of 5, that sort of thing. But I mean, I think, it is tricky. As I said earlier, I've got friends who post up avatars, and sometimes they post up themselves. And I often look at it on social media and think, ooh, which one's which? It's getting increasingly difficult to spot, if I'm honest, particularly because they can kind of clone their own image now. But, if you looked closely at the video I showed earlier, you would see that there are elements of, there's sort of micro glitches, like I might suddenly do something which you think, well, that's a bit odd. But yeah, I think ultimately it's going to get harder and harder. So if you look very closely, I think you can see the cracks still. Whether you'll be able to see them in 5 years' time, I honestly don't know. I think it's going to become very, very difficult to spot the difference.
Yeah. Okay, I've got a question from Hugo that I'm hoping you'll understand, Alan. Could you suggest a couple of tools that are good to work with more narrow models?
Yeah, I mean, so if you were building your own on a MacBook or something like that, for example, I use one called GPT for All, which then gives you access to about 5 different LLMs to choose from, things like Mistral, GPT, Anthropic, and you can essentially then upload your own data set into that. And yeah, I did something for a friend recently, actually, just as an experiment for him, who's a lawyer, and we were able to upload some information on, some key law documents, and then create essentially a bot that he could talk to, around the kind of subject of law, which was very, very useful. So that's quite good. The Olama is another one that's quite popular on device as well. And the beauty of these ones is that it's not throwing anything out to the cloud. You download the model onto your device. I mean, typically they take about 8 to 10 gigabyte, depending which model you're pulling in. And then you can add your own data set to that. So you need a bit of headroom, you need some RAM. It needs to be a fairly decent laptop, but yeah, absolutely possible.
Okay, we're going to have to wrap up in a couple of minutes. There's one question that might more be a mission for us to take away as the IMechE from Martin. Have the IMechE developed a library of use cases for exploitation from product design through to production? If not, it would be very helpful as a starting point rather than orgs doing this from scratch. I'm guessing the answer to that is no, Alan, but it might be something that we consider doing in the future.
Yeah, I mean, the answer is definitely no at this point. I know we haven't done that, but yes, I mean, it could be something that could be looked at. Yeah, for sure.
Okay, I think I'm going to wrap it up there, everyone. So thank you to Alan for his brilliant presentation and answering the questions so well. Thank you to all of you for dialing in. If we didn't get to your question, you can email us. My contact details are available, but the best address to use is probably policy@imeche.org. If you send any questions or comments through, any feedback as well, we'd be happy to reply to you. A reminder that you'll get an email with a link to our report. Please do download and read Alan's report. And eventually this webinar will be available on our YouTube channel, so you can rewatch it or share with your friends and colleagues. So thank you very much for listening, and goodbye.
Thank you. Goodbye.